answer key. So circuit questions are there with answer key. We did question 1. The logic gates are not there anymore, the part of a syllabus. We did question 2 as well in the last session. So today we will do question 3. In question 3, you can see a current and voltage graph. For a current voltage graph, when current is on y-axis and the voltage is on x-axis, the slope is reciprocal of the resistance. So slope is 1 over r. So if the slope is decreasing, as you can see from this shape, if the slope is decreasing, it means the resistance is increasing. And opposite will happen. If the graph was the other way around, like this, the slope is increasing. If the slope was increasing, the resistance will decrease. And what if it was a straight line? So if it was a straight line through the origin, it means the slope is not changing. It means the resistance does not change. So we may have different types of the graph. We may have a slope increase, slope decrease, or slope constant. So if the slope is decreasing, it means the resistance of the component is increasing. So figure 9.1 shows a graph for current against the potential for a filament lamp. And for a filament lamp, as it's a metal, so for metals, as we increase the temperature or as the temperature increase, the resistance will increase as well. How I know that the slope is reciprocal of the resistance? Because the slope is equals to the quantity on y-axis divided by quantity on x-axis. That's a slope. So which quantity on y-axis? Current is on y-axis. And which quantity on x-axis? Voltage. So it's I over V. And we know resistance R is equals to V over I. So resistance is a ratio between voltage and current, but here slope is I over V. It's opposite of that. That's why we say slope is equals to 1 over R. Because it's slope is quantity on y-axis divided by quantity on x-axis. So it's I over V, but the resistance is V over I. So I over V means it's a reciprocal of the resistance, or 1 over R. So it means that if the slope is decreasing, the resistance will increase. State what happened to the resistance of a filament from 0 to 1 volt. What happened to the resistance? Do you find any change from 0 to 1? It's a straight line. This part. Is there any change in resistance? If it's a straight line.
No.
So there is no change in resistance, so we can say it is constant. But then what happened from 1 volts to 8 volts? This part, the slope is decreasing. It means the resistance is... No, there is a slope, but the slope does not change. Here we don't say there is no slope. Here we say the slope is constant. So if the slope is constant, it means the resistance is also constant. But for this part, what happened? The slope is decreasing. So if the slope decreases, what happened to resistance? It will
increase.
So this part, the resistance will increase. The next part, at a normal brightness, the potential across the lamp is 8. Calculate the resistance. How to work out the resistance? If the lamp is having an 8 volt, the graph is given to work out the current. So what you will do, from 8 volts, when the voltage is 8 across the lamp, how much is current flow through this lamp? What is the current? So 10 boxes equals to 0.2. Each box is 0.02. So this is 0.62, 0.64, 0.66, 0.68, 0.70, and 0.72. So this one is 0.72. So we have the voltage and we have the current. We need the resistance. Resistance is a ratio between voltage and current. So voltage is 8 and the current is 0.72. Yeah, so each box is representing 0. Because 10 boxes equals to 0.2. So each box is 0.02. That's why it was 0.62, 64, 0.66, 0.68, 0.7, 0 and 0.72. So 8 divided by 0.72, what's the answer for this?
11.
11.1.
So 11.1, the resistance is equals to 11.1. And the unit of the resistance is ohm, which we represent by omega. So here we'll write the resistance, it's a ratio between voltage. Why it is of 3 marks? Because you have to use the graph, and whenever you're using a graph, you just don't write the number. Like what is the common mistake student used to do? They just like voltage divided by current, you write 8 divided by 0.72 and you got 11.1 ohm, but still you will score 2 marks. Why not 3? Because 1 mark is to show on the graph that how you got this current. So how you represent, so you have to draw these lines on the graph. So you will draw a line from 8 volts and find how much is the current. So drawing these lines is having 1 mark. If you don't draw the line and you just got the answer from the graph, you will lose 1 mark. So whenever you're using a graph, show on your graph how it is done. The power of the lamp, if you want to work out the power of the lamp, we have the formula power is a product of voltage and current. So voltage is 8 and the current is 0.72. What's the answer for this in watts? What's the answer here?
5.76.
So 5.76 joules per second or watt. 5 of these lamps at a normal brightness are connected in parallel to the power supply. Determine the EMF of the power supply. Like their normal brightness, so each lamp is 8 volts. So each lamp is having 8 volts. And we know when lamps are, when a component, the components are connected in parallel, what is the characteristic of the parallel circuits? So if 2 or more components are in parallel, they will have the same voltage as the supply and the current will divide. So they will have a different currents. If identical, so current will divide in the branches, but voltage is same. So if all are having a 8 volt, what is the EMF of the supply? So what will be the EMF of this supply? If they all receive same voltage, 8 volts, so EMF of the supply will be 8 as well. Because whenever components are connected in parallel, the voltage of a supply is same as the voltage across each component. And what if they were in series? Like example, if I say there were 3 lamps which were connected in series. So there were 3 lamps which were connected in series and each was receiving 8 volts. So this was 8, this is 8, this one is 8. Now what is in that case, what will the EMF of the supply? So it will be 8 plus 8 plus 8, which is equals to 24. EMF means electromotive force or the voltage of the battery. The voltage of the battery, when the electrical and chemical energy changes to electrical energy, that's called EMF. So voltage of the supply is also known as electromotive force. And the energy consumed or energy transfer in the component is known as the potential difference. Both are voltages. Voltage can be EMF, voltage can be potential difference. If it is from the supply, we call EMF. If it is across the component, we call that as a potential difference. So whenever the devices or components in parallel, they will have the same voltage but different current. And if they are in series, the voltage will divide and the current will be same. So the EMF of the power supply, it will be 8 here without calculation. You can write. Why? Because they all are in parallel, so they will have the same voltage as a supply. The current from the power supply. How to work out the current from the power supply? There are 5 lamps in each lamp. When there is a 8 volt, each lamp we already worked out the current in each lamp was 0.72 ampere. Because this is a continuation of the question. This is also 0.72 ampere. This is also 0.72 amperes. This one is also 0.72 ampere and 0.72 ampere. So they all have the same current But the question is, what is the total current from the supply? So how we work out the total current from the supply? So it will be 0.72 in each branch and number multiplied by number of the branches or component, that's 5. So 0.72 multiplied by 5. What's the answer?
3.6.
So means the total current is equals to 3.6. So this will be 3.6 ampere. And this was 8 volts. So this was question 3 from exercise circuit questions with the answer key.